Hello, welcome back to my channel. Today I will introduce how to using the Lula IK and the Differential IK for the XleRobot in the Isaac Sim or lab. And I will introducing the how to build the extension for the Lula IK and how to prepare your standalone script for the Differential IK. So first of all, you need to download the XleRobot. That's a great robot. You can build it by your own. All you need is a simulation asset. They already prepared two type of the asset, but at this time, the mini scale is good for using the Isaac Sim. So what you need is download the assets here and find out the URDF. That one is sufficient, and you also need the mesh. And then you need to build your own Isaac Sim, download it. Currently, I'm using the Windows, so I prepare it at Windows. I download everything here. Then what do you have? I will show I have already downloaded them. In this place, I have the URDF, I have the mesh. Mesh is actually for the robot assets, such like how to look like, what's the color, how heavy it. But URDF actually is an XML file. You can know what the joints and what the link and the parameters for them, and you should prepare for them and go back to the Lula IK solver. You can see there is already an example. You can download it and play with the example. So I basically follow this example, build a similar extension and run it in the Isaac Sim. There is a key code, prepare the scenario there. And yes, here is a demo. So ultimately, I will build similar things like this. And yes, let's go to the code. I also downloaded in the example, you can see what the file looks like. They have a core part is a scenario, everything about the Lula IK in the scenario. And other things mostly about how to using the extension. So let's go for run it, check my code. I have also my scenario. So in the scenario, what do you need? You need the URDF, which we already have, but you also need the USD. That's required for the Isaac Sim. And another important is a critical is a YAM file, is another type of the config file. So what is YAM file? You need to go back to that was a requirement for the Lula kinematics solver to configuration is a URDF that we already have, but there are another things we need is a YAM file. It will introduce how you build a C space. It's a configuration space. You don't worry about the USD file because it will be generated by the Isaac Sim when you import the URDF. And what you need to do is prepare your YAM file, is a configuration file. And let's go to try to use it. Go to your Isaac Sim and then start your app. I'm using the GTX 3060, so it's not very powerful or even not the recommended graphic for the Isaac. You're gonna have a better graphic card. And at this time, we could input the URDF file we already have. And when we input it, it will mention that you will have a USD file. So at that time, you have the USD file there, and you can use it in the extension. Yes, I will create it. Now we have the robotic inside. So what do we want? And then we should prepare our YAM file. There is tools in the robotics that will have a Lula robotic description editor. That's a YAM file. Generate place. And we cannot select link because we didn't play it. When we play it, all the joint can be choose, such like the rotate. You can change the value here. And is that good? Currently, all the joints are fixed. You should pick up your C space movable the joint. So I prepare the right side. I set it to be active, rotate, pitch active, and elbow active, and with the pitch active, with the roll active. So we have 5, 1, 2, 3, 4, 5. 5 active joint, and the other joint should be the fixed. So when we calculate the left side, we're using this YAM file. You could try the spheres for the collision later, but at this time we do only introduce the export it. You should go to the photo to save it. Go to my photo. Let's put everything together. That's it. Yes, and you should name it the YAM file. It's the right side, right arm. You don't forget. You should know. I got save. Yes, we have it. Now we could close it to check the YAM file. Now we have the YAM file. Defaultly, the YAM file looks like this, but what I want to introduce is the YAM file should contain the root link. Why I know that? If you do not include that, your Lula IK won't works well. That root link is not default by the generate. And why I know it? Because I have reviewed the example. This one is perfect for the Lula IK. And another thing you should prepare is you should change your URDF file, because defaultly the URDF file sets the velocity to 0. That's not be allowed in the Lula IK. You should change the value. So my prepared Lula IK URDF, I have updated the value of the velocity. No velocity should be 0, so that will be work for the Lula IK. So that's another step. You should prepare your URDF. Then all the files prepared, and I'm gonna introduce what I have done in the Lula IK, how to make it works in my scenario, because I find the issue is it's not move in my scenario, because Lula IK have a very low tolerance, not very good for the scenario. Only part of the action will be shown, so I apply the near solution anyway to converge the cross steps. So I will apply the action despite the IK failure. So that's what I changed to make sure the action can be work. So let's show how it works look like. I open this. Now I will tell you how to connect your photo about the extension and how to load the extension, and we prepare the extension here. We already have the extension, but before that you should go to the extensions, and third party is my extension, but you need setting that and go to add your directory. But that is a tricky here. You cannot double click. You should very quickly go double click it and add your direction as pass. I already put it on there, and then I could click my extension here, load it, my robotic show, and alright, I run it. I have 2 targets, which I can control the target access to change it. It's a little bit slow, but you could adjust that and how to the left. You can see that the movable is very reasonable. When I towards back to the arm, the elbow will be works well, and when I up it, down it, all the joint, because Lula IK have the weight for the joint and the task. So the weight will decide which elbow, which joint will be work. And I can also using the orientation to change the orientation. So that works very well. So that's all of the Lula IK and the extension. Now let's talk about the differential IK. In the differential IK, we directly using the Isaac lab um, because my previous colleague supplies Isaac lab code, so I built from that. That's why I'm using the Isaac lab instead of the extension. But what I want to let you know is because this is a floating base robotic. So in the floating base robotic, we calculate the jacobin's shape is different from the fixed base. There is a offset because the floating base will be bigger than the fixed base Jacobin size. So there is an offset. We should calculate the offset. What is base offset? In the floating base, the whole robotic will have the base still F. So we need to know the offset size. And when we calculate the left arm still F, we should calculate the offset and get the correct Jacobin's column. Instead of that, you will get the totally wrong columns to calculate the differential IK. So that's a place we should be attention. And yes, let's go to the. Yeah, so I have to the condition here. If the fixed, we do not need to do that. If the floating, we should have this place to get the correct columns from the Jacobins. And additionally, I also added adaptive damping for the lambda value. So I set this function in my code because, as you know, the differential IK is a plain IK. It do not have so many strategies to make the move more smooth or more faster and stable. So you need more strategy to optimize it. So in my code, I have adaptive damping function, and I also have the gate. I set the gate here. If the value arrow is more than certain arrow, I don't want to make the arm move chaos. So I set the gate. And I also compared with smooth and limited the sounds. It's a low pass filter, and I find that it's not ideally, so I didn't use it in my code. But I put it here as a comparison. I think yes. So I think that's all I want to introduce about the IK, and let's try to run it. Differ from the extension, we need using the code to run this one. So I prepare this one. Compared with the extension, you do not need a URDF. What you only need is a USD file. So USD file is not readable, but using other script to generate some architect, I can know what's exactly in this robotics of the USD, and I can run it. In my code, I directly load this robotic USD file and build it in a scene and define the joint. I do define joint in the IK. So there will be the end effector and the whole joint chain. Yeah, that's right. It's a standalone script. It will create the Isaac Sim based on by using the Isaac lab, and it's movable. My colleagues already prepared the move based command. I can use the keyboard move. It is W A S D. Yes, so ASD, and I go right. I go left. I also can rotate. And for my side, I prepare the IK move ball. I could turn on the ball, let you know. I can change the value of the transfer. Oh, it's too big. I have the coordinate. I can change the whole robotic arm. I can go this side. I can change the rotate. and I can still move. So the IK is still active, but I do think the target with the arm, so they will not be conflict. I also have another strategy like using the cooldown of the sync and avoid the conflict and the initial momentum. That's it. Thank you for watching, and I think I also will place some other comparison of the video after that about how I optimize them. You could try yourself, and if you have any question, you can comment, and I will release my GitHub repository soon. And because I also build something other task on that, let me know what's your question, and I think I can help you some. Okay, bye bye.